Rebar Detailing, British Standard. Introduction and Drawing Flow. Hello everyone, and welcome to Rebar 360. I'm delighted to welcome you to this training series on rebar detailing based on British standards. Whether you're a civil engineering student, a graduate looking for career opportunities, a site engineer, or someone interested in learning rebar detailing, this course has been designed to give you a strong practical foundation. Rebar detailing is one of the most important disciplines in reinforced concrete construction. Every beam, column, slab, wall, and foundation requires reinforcement to be fabricated and placed exactly as intended by the structural engineer. The rebar detailer is the professional who converts engineering designs into practical shop drawings that can be fabricated and installed on site. In this course, we'll not only learn how to prepare reinforcement drawings but also understand the complete workflow, from reading structural drawings to preparing bar bending tools, coordinating with engineers, and following the requirements of BS 8666, the British standard for scheduling, dimensioning, bending, and cutting reinforcement. Objectives of this course. By the end of this course, you'll be able to understand what reinforcement is and why it is essential. Reinforced concrete. Learn the fundamentals of rebar detailing. Understand the complete drawing workflow used in construction projects. Become familiar with the British standard BS 8666. Identify the different types of engineering drawings used throughout a project. Throughout this training, I'll share practical examples, industry best practices, and tips gathered from over 2 decades of experience in rebar detailing. So, if you're serious about building a successful career in rebar detailing, you're in the right place. Let's begin by understanding the most fundamental question: what exactly is rebar? Now let's begin with the most fundamental question in reinforced concrete construction. What is rebar? The term rebar is short for reinforcing bar. It is a steel bar that is embedded inside concrete to improve its strength and structural performance. To understand why rebar is needed, we first understand the behavior of concrete. Concrete is an excellent construction material because it has very high compressive strength. In simple words, it can carry heavy loads that push down on it. That's why concrete is widely used for columns, foundations, beams, slabs, bridges, and many other structures. However, concrete has one major weakness. It is very weak in tension. When concrete is pulled, bent, or stretched, it tends to crack easily. This is where steel reinforcement comes into the picture. Steel has excellent tensile strength. It can resist stretching and forces without failing. When we combine concrete and steel, we get reinforced cement concrete, commonly known as RCC. In an RCC structure, concrete resists compressive forces. Steel reinforcement resists tensile forces. Together, they complement each other in a strong, durable, and safe structural system. Why reinforcement is required? Concrete is an excellent construction material, but it has one major limitation: it is strong in compression but weak in tension. Structures such as beams, slabs, columns, and foundations are subjected to various loads, including self-weight, occupants, vehicles, and earthquakes. Concrete alone cannot safely resist all these forces, which is why steel reinforcement is essential. 1. Prevent cracks. Concrete naturally develops cracks due to shrinkage, temperature changes, drying, and external loading. While small cracks are normal, uncracking reduces durability and appearance. Reinforcement distributes tensile stresses, ensuring cracks remain small and well distributed, improving long-term performance. 2. Improve tensile strength. In a loaded beam, the top is mainly in compression while the bottom is in tension. Without reinforcement, the tension zone would crack and fail. Steel reinforcement is placed where tension occurs, allowing steel to resist tensile forces while concrete carries compression. This principle applies to beams, slabs, retaining walls, and foundations. 3. Increase load carrying capacity. Reinforced concrete members can safely support much greater loads than plain concrete. Reinforced beams carry heavier loads, columns resist higher axial forces, and slabs span longer distances with reduced cracking and deflection. Modern buildings, bridges, and high-rise structures rely on this combination of concrete and steel. 4. Enhanced durability. Proper reinforcement detailing improves the service life of a structure. Adequate concrete cover, correct bar spacing, proper lap splices, and sufficient anchorage protect steel from corrosion and ensure structural integrity. Poor detailing can cause congestion, inadequate cover, corrosion, and premature deterioration. The role of the rebar detailer. Structural engineers design the reinforcement, while rebar detailers convert those designs into accurate shop drawings and bar bending schedules, BBS. Good detailing ensures reinforcement is fabricated and installed exactly as intended. Simply put, good detailing ensures that the design strength becomes the constructed strength. Real project example. Consider a residential floor slab. As people walk or place furniture on it, the slab bends slightly, creating tensile stress. Without reinforcement, visible cracks would develop, reducing both durability and appearance. Reinforcement absorbs these tensile forces, controls crack widths, and keeps the slab safe throughout its service life. What is rebar detailing? Rebar detailing is the process of converting a structural engineer's design into clear, accurate construction instructions. While structural drawings specify the required reinforcement, they do not provide all the information needed for fabrication and installation. A rebar detailer prepares the details required by fabrication yard, what bars to cut, bend, and how many are required. Site team, where and how each bar should be placed. The two main outputs. 1. Reinforcement shop drawings. Shop drawings provide detailed information for construction, including bar locations and sizes, spacing and bar marks, sections and details, concrete cover, lap locations, construction notes. These drawings eliminate guesswork and ensure reinforcement is installed correctly. 2. Bar bending schedule, BBS. The bar bending schedule, BBS, is the fabrication document containing bar mark, bar diameter, shape code, cut length, quantity, weight. Fabricators use the BBS to cut, bend, bundle, dispatch reinforcement accurately. Rebar detailing is more than drafting. Professional rebar detailing involves reading structural drawings, understanding design intent, applying detailing standards, e.g. BS 8666, checking constructability, coordinating with other disciplines, preparing accurate BBS, managing revisions and resolving drawing issues. A rebar detailer is not just a CAD operator, they are the link between the design office, fabrication yard, and construction site. Why it matters. Accurate detailing reduces errors, material wastage, delays, and costly rework. It improves fabrication quality, speeds up installation, and ensures the structure is built as designed. Real-world example. A structural drawing may specify T20 at 150 mm C/C for a beam, but it doesn't provide the cutting length, bend shape, hook details, or quantity. The rebar detailer converts this design information into shop drawings and a BBS, making it ready for fabrication and construction. Key principle. Structural drawings tell us what is required. Rebar shop drawings tell us how to build it. Role of a rebar detailer. A rebar detailer is the link between the structural engineer, fabrication yard, and construction site. Their job is not just drafting reinforcement but ensuring it is fabricated and installed exactly as designed. Key responsibilities. 1. Understand structural drawings. Before detailing, a rebar detailer studies member sizes and levels, reinforcement and general notes, sections and details. Design intent. Good detailing starts with good drawing interpretation. 2. Prepare shop drawings. Shop drawings provide clear instructions for construction, showing reinforcement layout, bar marks and diameters, spacing, Lap locations. Concrete cover. Sections and construction notes. The goal is to ensure steel fixers can place reinforcement without guesswork. 3. Prepare the bar bending schedule, BBS. The BBS provides fabrication details such as bar marks, cut lengths, bend shapes, quantities, total weight. An accurate BBS minimizes waste and fabrication delays. 4. Follow industry standards. Rebar detailing follows standards such as BS 8666, which define shape codes, bar scheduling, dimensioning methods, bend details, bar notation. Following standards ensures consistency and reduces mistakes. 5. Coordinate with project teams. Rebar detailers work with structural engineers, architects, MEP engineers, fabrication teams, and site engineers. They identify drawing conflicts, seek clarifications, and raise RFIs when necessary to prevent construction issues. More than a CAD operator. Professional rebar detailing requires engineering judgment, coordination, communication, problem solving, attention to detail. A skilled detailer improves quality, reduces rework, lowers costs, and increases construction efficiency. Career growth. With experience, a rebar detailer can progress to roles such as senior rebar detailer, checker, team leader, project coordinator, coordinator, rebar detailing manager. Professional tip. Never detail what you don't understand. If a drawing is unclear, review related documents, discuss with your team, or raise an RFI. A few minutes of clarification can prevent days of costly site delays. Construction workflow. Understanding where rebar detailing fits in the construction process helps detailers see how their work connects design with construction. Every successful project follows a logical sequence. Step 1. Architectural design. The project begins with the architect, who develops floor plans and elevations, building sections, room layouts, staircases, doors, and windows, architectural finishes. These drawings define the building's layout and functionality. Step 2. Structural design. The structural engineer designs the load-bearing system by calculating dead, live, wind, and earthquake loads. They specify foundations, beams, columns, slabs, and walls. Member sizes. Concrete grades. Bar diameters, spacing, and reinforcement requirements. These drawings show what reinforcement is required, but not how it will be fabricated. Step 3. Rebar detailing. Using structural and architectural drawings, project specifications, and revisions, the rebar detailer prepares reinforcement shop drawings showing bar locations, bar marks, concrete cover, laps, and detailing. Bar bending schedule, BBS, containing shape codes, cut lengths, quantities, and weights for fabrication. The structural engineer specifies what is required, the rebar detailer shows how to build it. Step 4. Construction. After approval, the fabrication yard uses the BBS to cut, bend, bundle, and dispatch reinforcement. At the construction site, steel fixers install the bars, engineers inspect the work, and concrete is poured. Accurate detailing ensures smooth fabrication and construction. Why it matters. A rebar detailer's work directly impacts fabrication yard, site engineers, steel fixers, QA/QC inspectors, project managers. Errors in detailing can lead to material waste, delays, and costly rework. The big picture. Think of construction as a relay race: architect, structural engineer, rebar detailer, fabrication yard, construction site. Each stage depends on the accuracy of the previous one. Remember. Architects define the building. Structural engineers design structure. Rebar detailers prepare construction-ready reinforcement drawings. Fabricators manufacture the reinforcement. Site teams install it. Professional tip. Always detail with the construction site in mind. Every drawing, dimension, and bar mark should make fabrication installation easier, ensuring the structure is built correctly the first time. Congratulations on completing the first lesson of our BS Rebar Detailing training series. Today, we've covered the fundamentals that every rebar detailer must understand before moving into practical detailing. We learned what reinforcement is and why it's essential in reinforced concrete. Why steel and concrete work together to form strong and durable RCC structures. What rebar detailing is and how it converts structural designs into construction-ready shop drawings. The important role of a rebar detailer in connecting design, fabrication, and site execution. And finally, we explored the complete workflow to understand where rebar detailing fits into a real project. These concepts may seem basic, but they form the foundation for everything you'll learn in the upcoming lessons. Remember, a strong building starts with a strong design. But a successful project depends on accurate detailing. Whether you're shop drawings, bar bending schedules, or coordinating with engineers and site teams, your attention to detail directly impacts the quality, safety, and efficiency of construction. So, take the time to understand these fundamentals thoroughly before moving on to advanced topics. In the next lesson, we'll explore the different types of end drawings used in construction and learn how architectural, structural, MEP, and shop drawings work together in a real project. If you found this video helpful, please support the channel by liking the video, subscribing to Rebar 360, and sharing it with your friends and colleagues. I'd also love to hear from you. Where are you from, and are you a student, site engineer, CAD engineer, or already working as a rebar detailer? Leave your answer in the comments below. I personally read every comment, and your feedback helps me create better content for future lessons. Thank you once again for watching. Keep learning, keep practicing, and I'll see you in the next lesson. Happy detailing!